Hey guys, sorry I couldn't be with you today. But this is the same thing I would have done if I was there, so hopefully I stop glitching. Whatever. All right, anyways, let's do this. So today we want to start to look at an example. This is, by the way, chapter 15. If you're a chapter person in your notes and you want to give it a title there. So chapter 15 in our textbook that we don't even have is called probability rules. You know, because we're like learning a bunch of rules and it rules. And our first example here, we want to start looking at events that overlap. So this is just our context. So take a second, read that. And my first question to you, right, so you can pause that and read it, but my first question to you is, how do we know that these events overlap? Right, so like right now, you should like pause the video, turn to the other people in the room and have that conversation, right? How do we know that these events overlap? And now that you've unpaused it, right, hopefully you guys all agree that we know these overlap because there is some percentage of students who take both courses. Now, my next question for you guys is, what's the like proper stats vocab? Instead of saying events that overlap, how would we describe these events using some of the vocabulary from our Delta Math video last week? Oh, that's right. Good job, everyone. Hopefully you all turned to your neighbors and decided that means these are events. What am I doing? These events are not disjoint. Right? Disjoint means no overlap. So these events do overlap, or they can both happen, right? A student can take both statistics and calculus. So these are not disjoint events. So up to this point, we've really heavily worked with events that are disjoint, right? Like in roulette, when you spin the roulette wheel, you can't get black and red. Those are disjoint events, right? There's no both. Or on the quiz you just took, all right, you're not going to spin the spinner and you're not going to get black and a gift card, right? You can't do both. Or same thing with the voter turnout, right? You can't show up to vote in 2016 and not show up to vote in 2016, right? So can't do both of those things. Those are all disjoint events. We've worked a tiny bit with events that are not disjoint, events that overlap, and that actually takes us back to the summer assignment. You might remember some two-way table questions, and maybe it was like, what's the probability like the person's male or bought pizza, right? And then when we added those totals, we had to pay attention to this overlapping section, right? And subtract that off, going back to the summer, maybe going back to geostats last year, right? But so this was working with events that are not disjoint with a two-way table, right? So now we want to work with similar types of events, just not with a two-way table. And again, we know these events are not disjoint. An easy way to recognize that is we're given the idea that some students take both. Now, sometimes you have to figure out if the events overlap. That happened in your AP classroom assignment, right? You saw there was a couple questions where there were tips explaining to you kind of formulaically how to figure out if there was an overlap, if there was a probability of A and B. And our warm up when I see you guys on Thursday, we'll have a question where you have to figure out if there's overlap and kind of figure out what that middle is. But if we're directly given a percentage of both, right, then we have an obvious situation where our events are not disjoint or overlap. For the sake of your notes, right, you don't have to like write this entire context in your notes. Below example 1, you can just say the probability that someone takes stat is 0.4. Probability someone takes calc is 0.15. And the probability someone takes both is 0.08, right? So for right now, really all you need is in your notes is what's like in all this marker, you know, the purple, blue, green, and blue over here. So when we have events that overlap, when we have events that are not disjoint, what I like to do is draw a Venn diagram. So we could take a formulaic approach to this, right? And you saw that referenced in the tips for the AP classroom assignment. And although we didn't name it the general addition rule, when we would add those two totals with our two-way table and subtract the overlap, that was kind of taking the formulaic approach. But another option, right, an option I like is a Venn diagram. So what I want you to do now, what do I have on the next slide here? What I want you to do now, so we try to draw the Venn diagram. So as we do this, a couple quick tips. One, label your circles. And so by that, I mean, when we go to draw this Venn diagram here, label which circle represents stat and which circle represents calc. I say that because this Venn diagram is going to be most of our work, right? Like, and then when we do A, B, and C, it's just going to be pulling numbers out of the Venn diagram. So sometimes I see students who create the perfect Venn diagram mathematically, but then they give me the wrong answers because they like use the stat number for calc and vice versa. So just label. So we need to fill in 4 numbers in this Venn diagram. So a couple questions. Turn and talk to your neighbors about these. One, what are these 4 probabilities we're going to fill in? What do they have to add up to? And the other question is, in words, like what's that red spot represent? What's this purple spot represent? What's this green spot represent? And what's this blue spot represent? So what do the red, purple, green, and blue represent like in words in terms of taking these courses? So pause the video, right, and talk as a class. Maybe even someone does this on the board up front. You guys work through it together. That'd be fantastic, right? And it kind of leads the class as the teacher. Try to label those in words and think about what those should add up to. Pause. Pause. And so now that you guys have talked about this, then unpause, right? These are the people who take only AP statistics. We know these are the students who take both. These are the students or the proportion or probability someone takes only calc. And then these would be the students who take neither. And then those should all add up to 1 because this is the entire sample space, right? If you're a student, you either take just calc, just stats, you take both, or you don't take any of them. Right, those are the only possibilities. So those 4 different outcomes, their probability should add up to 1. So now that we got the kind of the outline of the Venn diagram here, now I want you to pause the video again. If we were in class, I'd have you turn and talk to your neighbors and try to figure out the values, right? We know these 4 spots, red, purple, green, and blue, have to add up to 1. I need you to use the information that we were given, right? This is what we wrote down earlier. And I want you to fill in the numbers that go in the Venn diagram. Talk to each other about that. Go. And now that you've unpaused it, I'm willing to bet that I see a lot of people with this. So if I were in the room, I know this would happen. I've done this a few times here and there, right? If I were in the room, I think I would see a lot of Venn diagrams that look like this. And then that would give me what, like 0.37 out here. But I'm going to tell you that these are actually all wrong. Not all, I lied. 1 of them. 3 of them are incorrect. Here's why. If we have these values in our Venn diagram, the total probability a student takes AP Stat, right, should be 0.4. But right now, if I look inside this yellow AP Stat circle, this doesn't contain 40% of the data values. This contains 48%, right? Because we've got this 0.4 here and this 0.08 over here inside the yellow circle. Similarly, the total probability, the total inside the calculus circle over here in orange, right? This should be a total of 15% for calculus. However, right now, this circle contains 23%, right? 15 here and another 08 over here. So if you did this in your Venn diagram, that's normal. That's what I expect everyone to do the first time. But we've got to make some adjustments, right? These are incorrect because right now the total yellow circle adds up to 48%. We only want 40. And right now the total calc circle in orange adds up to 23%, 15 plus 8. We only want 15. So that means we've got to adjust some of these values. And now, of course, you pause the video again and you work together as a class. Maybe one person's leading it on the board again. I don't know, right? And now you fix the numbers, right? We got to fix that problem. Remember, the total stat circle should add up to 0.4. The total calc circle should add up to 0.15. We do know that both is 0.08. So in general, we want to fill in the middle first. And I'm confident that we now realize this has to be 0.32, right? 0.4 minus that 0.08. And now inside this yellow calc circle, inside this yellow stat circle, we have a total of 40%. So that matches what we were given. And then over here, right, this is going to be 0.07. We have to subtract off that 0.08 from the 0.15, right? That's already included. I'm not sure what's happening here with my marker. So 0.15 minus 0.08 gives us that 0.07. And now inside my orange calc circle, I have a total of 15%, right? 8 and 7, which matches this. Then if I subtract all that stuff from 1, oh, that's not blue. If I subtract all that stuff from 1 minus the 0.32 and minus the 0.08 and minus the 0.07, that gives us 0.53 out here. And so now we have our correct Venn diagram. Our probability sum to 1. Total in the stat circle is 40%. Total in the calc circles 15%. So we're good to go. That's most of the work if you use a Venn diagram. Now let's answer the questions. So from here, it's just using our Venn diagram. I should have kept my color scheme consistent, but they're the same ideas. So letter A. Again, so in your notes, like you can just write A, what's the probability a student takes neither course? And that's easy. That's just that 0.53, right? That's just this number right here on the outside. So like if you had the Venn diagram, like that is all of your work. Now, if I'm gonna add or something, numbers from the Venn diagram, I have to show that arithmetic, but if I'm just pulling a number out of it, the Venn diagram is the work. I'm gonna jump down to C. C in your notes, what's the probability a student takes only calc? Again, that's just a number we're pulling right out of our Venn diagram. That's now this 0.07 or 7% over here. No big deal. And then the one question that makes us think a little bit, what's the probability, go some green. For B, you could say, what's the probability a student takes stat or calc? Think about that. Pause the video, talk about it as a class, work together. You got this. What are we thinking? Now, I'm willing to bet, whenever you like, pause it if you didn't already do it together. I'm willing to bet that we've got a lot of 0.39s. A couple things. Don't just write 0.39 because that's not a number we're pulling out. If you're doing that, show me the addition. So I bet I see a lot of 0.32 plus 0.07. And that's decent. But as you look at the Venn diagram, right, we just want to think, did these people take stats or calc? So like here, did these people take stats or calc? Yeah, they took stats. Did these people take stats or calc? Yeah, they took just calc. So we definitely want to add these. But did these people take stats or calc? Well, yeah, they took both. So they did take stats or calc. Like, am I absent or in a video today? Yeah, I am, because I'm both. So we also want to add the 0.08 here. So on the AP exam, if a question, what's that, 0.47? If a question, two things. If we're going to add numbers, we got to show that arithmetic, right? So we got to show that green addition here. But also, if they didn't want you to include the 0.08, the question would say, what's the probability a student takes stats or calc, but not both? And to finish up this lesson for today in this video, there's a couple other ways we could do this. Can you think as a class, pause the video, what are two other ways we could do this? And there you play again. One other option, we could do 1 minus the neither people, right? Because if you take stats or calc, that means you don't take neither course, right? You take one of them, right? So you're not in the neither category. So that's another way we can get 0.47. Or we could go back to the type of thinking we used in the summer academy, the summer classes that didn't exist, but our summer assignment, where we could take the total for stat plus the total for calc, but then we have to subtract that overlap so it doesn't get counted twice. Because when we add the total for stat, this 40% is including the 8%. This 15% is also including the 8. So the 8's getting used twice. It's getting used with the 40 and with the 15. So we have to make sure we subtract that, right? Subtract that overlap. This is what we did with our two-way tables in the summer, right? And that also gives us that 0.47. So that's it for today. Have a wonderful day. I'm sorry I couldn't be there with you guys, but this is what we would have done anyway. So I guess technology worked in our favor today. I'll see you all on Thursday. Assignment coming for later, for tomorrow. Later, the papers in the classroom on the gray card if you want to grab.